This video will identify many of the most common drilling problems and discuss how to prevent them. Pipe failure occurs when the mechanical limitations of the pipe body, welded areas, or threads are exceeded. Potential downhole conditions and events that can cause pipe failures include severe doglegs, high friction factors, stuck pipe, and excessive tension. By inspecting the drill string and controlling the dogleg severity, pipe failure can generally be avoided. Lost circulation occurs when an uncontrolled flow of drilling mud into the formation is experienced. Preventing lost circulation requires managing the drilling fluid density and adding lost circulation material. Hole deviation is present, beginning with the first foot drilled. The bit tends to deviate from the center path during vertical drilling operations because of formation dip angles and heterogeneous rock textures. When drilling deviated holes, gravity becomes a major factor. Maintaining a consistent direction while drilling requires utilizing a well-designed BHA, selecting an appropriate bit, tailoring operational parameters, and evaluating the geology. When the annular pressure is greater than the pressure in the formation, a suction on the work string can cause differential sticking. The drilling fluid properties can be managed to help prevent pipe sticking, and lubricious additives or a slick mud system like oil-based mud can be used to reduce drag. Proper selection of a pipe with adequate tensile capacity and the use of jars can help free differentially stuck pipe. Borehole instability is often associated with rock failure due to earth stresses, unsuitable circulation pressures, chemical interactions between the mud and formation. Mud engineers treat borehole instability by maintaining proper mud weight in ECDs and keeping the mud compatible with the formation. Mud overtreatment, solid additives, or drilled materials accumulating in the mud system can all lead to mud contamination. Mud fluid thickening and an increase in viscosity during tests are a sign of mud contamination. Constant monitoring allows mud engineers to catch any changes in the mud properties. Pre-treatment and regularly scheduled treatments help the mud maintain its desired properties. The mechanical process of drilling a new hole will crush, shear, and otherwise damage the formation. Solids plugging, clay swelling, emulsion blockage, and aqueous filtrate blockage are also collectively referred to as formation damage. Underbalance drilling, stimulation operations, and the use of drill-in, workover, and completion fluids are used to protect or increase access to the hydrocarbon-bearing formation. When the volume of cuttings generated while drilling exceeds the volume of cuttings transported out of the hole, a buildup of cuttings, known as cuttings beds, occurs. Low annular velocity, highly deviated or horizontal well bores, and a high rate of penetration are some known causes of cuttings buildup. High annular fluid velocities assist cuttings removal. The pumping rate, fluid properties, and rotation speeds also affect hole cleaning. Drilling operations involve a highly complex and interconnected system. However, preparing for such obstacles will ensure that navigating the downhole environment will not be as challenging as it might otherwise be.